Now with ping, we can also do what is known as an extended ping. What can we accomplish with an extended ping? A whole lot. So for example, in this case with ping, our protocol is going to be IP. There's our destination address. Now what can we do? We can change our repeat count. So if I want to, I can change a repeat count so that way there, instead of sending out 5 packets, let's just send out 1 packet instead. Or maybe I want to have a ping that sends out 100,000 packets because I just want to keep pinging because I'm trying to fix connectivity. So I just have this continuous ping going on, 100,000 packets, ping while I'm working on the side here, making some changes, and all of a sudden the ping starts to work. So I can just leave it running if I want to. So this is going to allow me to change my repeat count. What else can we do? We can change our datagram size. The default datagram size is 100 bytes, but if I want to change my datagram size to 1,500 bytes, I can do so. How would that help me? Well, remember, this is a packet. When we take packets, before we can send them out on the physical wire, what do we have to do? Yeah, put them in a frame. What's the maximum packet size that can go in a frame for fast Ethernet? Do you remember? It's 1,500 bytes, right? 1,500 bytes. So I could essentially set this to 1,500 bytes and see what happens. I could set it to 1501, 1502, 1503. So I could use this datagram size field if I wanted to test MTU sizes on the network from a source to a destination to see if fragmentation's happening, to see if packets are getting dropped because they're too big. So it allows me to mess around with the datagram size. I can also change the timeout value as well. By default, it's 2 seconds. Maybe I want to allow it to, just take a little longer. Give it 3 seconds or 4 seconds because maybe we know, we're not getting our ping response because the network's kind of slow or congested or it's a WAN link, whatever it happens to be. We might want to, increase it to 5 seconds or maybe set it to 1 second. Set it to 0. I don't want to wait for a packet to return. I just want to generate artificial traffic with my ping for testing verifications. Could do that as well. Now, extended commands, yes or no. If you say no, then pretty much the ping is going to happen at that point in time. But if you go to the extended commands, you can start specifying source address if you want to. So what interface do I specifically want to source these from? Do you want to implement some type of service value in this packet? So I can mimic what? Mimic what? Voice traffic or video traffic. So if we prioritize voice traffic with a value of 5 and video traffic with some other value, we could essentially just emulate relatively quickly a voice packet and see how it's affected as it moves through the network. Emulate a video packet and see how it gets treated through the network. Could do that. Could set our do not fragment header, the do not fragment bit, for the IP header. Essentially, with IPv4, what happens is that if a router receives a packet, and the packet's too big, the router will fragment the packet. So if the packet's too big, the router will fragment it, meaning break it up into smaller chunks so it can leave the interface. But what we can do in this case is we can say, do not fragment. Do not fragment. So we could tell the routers, if the packet's too big, do not fragment it, which means that our ping would fail at that point in time. Because IPv4 routers are designed to fragment the packets if they're too big. Maybe that is causing problems in our network. Maybe it's not. So I could set the bit here to do not fragment. And as a result, the router would then not fragment it, and then the packet would be completely dropped instead of being fragmented, allowing me to verify if there's any MTU discrepancies in the network or anything that's going on. So think about it this way. What if we set our datagram size to 1,500? I said, do not fragment, and my packets are getting dropped. That means at some point in the network, there is an interface that is not allowing an MTU of 1,500. And I would know which router it is because that would be the router that's responding back to me, telling me that ping has failed, getting a return from that device. We can validate our reply data if we want to. Data pattern. We can also sweep a range of sizes as well. So we have the ability to sweep those MTU sizes. That's what this is about. So if I want to figure out what is exactly the maximum MTU, well, I could use ping to figure that out. I could say, yeah, I want to sweep a range of sizes, and this is the range I want to sweep. So let's say let's sweep from 1,400 to 1,500. then what that means is if I have a repeat count of 1 here, I will send 1 ping packet for every size. So I'll start off with 1400 bytes, then I'll go to all the way up to 1500 bytes. So 1401, 2, 3, 4. And then the pings will be success. Oh, as well as setting the do not fragment bit to no. So that way there we do not fragment. And then as it's pinging, and then we start seeing failures, then I know what the maximum MTU is on that path. So as you can see, there's a lot of really cool things we can do with ping. A lot of really cool things we can do. In this case, right at the very bottom, you can see that the ping was successful in this particular example. And let's not forget about Telnet. A lot of people think that Telnet is just utilized for remote connectivity, for administering our devices from remote locations. But in all honesty, let's think about this from a troubleshooting standpoint. What I can do with my Telnet command is test the transport layer. I can. I definitely can. This is going to work really, really well if we want to verify if a connection is allowed to a particular device using a specific port. So in this example here, we say, hey, let's go ahead and telnet to 10.10.50.2 using port 80. So what this is going to allow me to verify is, are we accepting HTTP port 80 web connections to 10.10.50.2? That's exactly what it's telling me. In this particular case, you can see open. Open means yes. Yes, it worked. It worked. But if we wanted to verify it even a little further, you can see here that we were able to get a little information back from the web server. Even though it's invalid information, doesn't matter. We had a response from it, and then it just completely closed down our session for us because, well, we're not a legitimate web browser. We're just telnetting from a command line prompt. But using Telnet to test a transport layer, another valuable troubleshooting tool you have at your disposal.